Welcome back to my channel, everyone. 3 tips here, and what I have is some silver nitrate granules, or silver nitrate crystals rather. Reagent grade silver nitrate. You see it down in there. And what we're going to do is we're going to make a video on converting this silver nitrate into high purity silver metal. What we'll do is first is add some distilled water to this clean beaker. Distilled water. I'm going to add about 500 milliliters or so of distilled water. Now what we'll do is add the silver nitrate to our distilled water. Got to use distilled water here. Can't use tap water. Tap water has dissolved chlorine in it, and it will instantly form, the chlorine will instantly form silver chloride, which is what we're going to do next. So I suppose you could use tap water here, but I'm using distilled water. I'm going to rinse it all out of the bottle. Silver nitrate is highly soluble in water, so I should be able to get this entire 500 grams of silver nitrate dissolved in that half liter of distilled water. I looked it up before I started this, and it said at room temperature I can dissolve 250 grams of silver nitrate in just 100 milliliters of water. See, there's some trash floating around in there. I don't know where that came from. This is ACS grade. ACS means American Chemical Standards. And here's the purity listed on the side of the bottle. It's got a little bit of a dingy yellow color to it. That reaction is cold. I mean, it's what you call it, endothermic. Endothermic, because it got real cold when I dissolved it in that distilled water. I keep referring to this as silver chloride. It's silver nitrate that we're dissolving in distilled water, and it's got just a little bit of a hint of color to it, a little bit of a yellowish tint. To contrast that, here's some of the silver nitrate that I've made for my silver cell. You can see it's crystal clear, colorless, like water. And I've got a Wattman number 2 medium flow filter in this filter funnel and flask. And so what I'm going to do now, we'll try to filter out some of the junk that is in here. You can see it's got just a little bit of tint of yellow to it. I don't know if you can see that on the camera, but there's a few particles of junk in here as well, so it's going to benefit us to go ahead and filter it, get all that junk out of there. Rinsing with distilled water. If we did use tap water here, we'd form silver chloride in here. It'd make this filtering operation a little more difficult. Here you can see there's some trash in our silver nitrate. We got it all filtered out. It took about 15 minutes to pull all that through the filter. And here's our clear silver nitrate solution. So now what we'll do, I'll rinse out the beaker with some distilled water, because we're going to be using the same beaker to do our reaction. So I want to get it all rinsed out real good. Get the rest of the silver out of here. And we'll run that through the filter as well. I'm using distilled water. I don't know what the trash is in here, but silver nitrate is light sensitive, and sitting in this bottle, it may have reacted with light over time and created some solids. We got them all out of there before we proceed with our reaction. Right now we're just going to get the funnel out of the way. So what I have now in this flask is silver nitrate that's been dissolved in distilled water. Silver and nitrate ions dissolved in distilled water. And by the way, I could take this, put it in a clean pan, dehydrate all the water out of here, evaporate all the water, and I'd get back nice, pure silver nitrate. I could do the same thing with a sample of my silver nitrate that I make from my pure silver crystal that I produce in my silver cell. Evaporate the water away, and I could make some nice, very high purity silver nitrate from some of my silver from my silver cell. What we're going to do now is just go ahead and add this to this beaker. The silver nitrate is clear and colorless like water. The silver nitrate from my silver cell turns blue because it has copper in it, and pure silver nitrate will not turn blue because there's no copper in it. I'm not a chemist, and I'm going by what David told me. What we have in here now is Ag, which is a plus, and NO3, which is a minus, ions in this solution. So what we're going to do is we're going to convert the silver nitrate in here with some hydrochloric acid. Right, the way I understand that is we're going to be adding H plus Cl minus. That's what's in here. The HCl will break apart, and the negative Cl ion will be attracted to the Ag plus ion and form AgCl, silver chloride. The positively charged hydrogen ion will be attracted to the negatively charged nitrate ion, and that will form HN03. That's nitric acid. This is silver chloride. And I'll probably end up with a little bit of excess hydrochloric acid in here, unless I did it perfect and converted all of it perfectly, but that's not going to happen. There's going to be an excess of hydrochloric acid in here. So what will end up when this is all done is silver chloride in a solution of hydrochloric acid and nitric acid, which, as we all know, forms aqua regia. I've got a little bit of tap water here in a beaker. And we're going to pour this into this silver nitrate solution to show what happens when we use tap water. The chlorine in the tap water should react with the silver nitrate and instantly form a cloud of silver chloride. I've never done this before. I don't know how this is going to work. Here we go. We're going to just add it right in. Well, that did not turn out like I expected. I thought we'd see some silver chloride form in there from the chlorine in the tap water, but that's not what happened. So now what we're going to do, I'm going to go ahead and add the hydrochloric acid in here, and then we'll see silver chloride forming in this beaker. First, let me dilute this down a little bit further with some more distilled water. It's an awful lot of silver nitrate to have in solution. Here we go. We're gonna start adding the chloride now. Hold on. Here we go. We're gonna add some hydrochloric acid into our silver nitrate and form silver chloride. Looks like cottage cheese. Nice and white and fluffy. Well, it's an awful lot of it. I mean, it's enough to cause my stirring rod to stand up by itself in there. This is our silver chloride down in here. It is right thick down in there. It's heavy. You can see chunks of solid silver chloride in there. Looks like cottage cheese. I'm going to put a little bit of sulfuric acid in here. See if any more silver chloride comes out of solution as I add this, and I don't see any. So I think I've got the proper amount of hydrochloric acid so that all of the silver nitrate has been converted to silver chloride. Here you can see it's stuck to the stirring rod, so you scrape it off with a plastic spoon. Silver chloride is light sensitive, so we'll just leave it out here in the dark and let it settle out and proceed from here. I've allowed the silver chloride to settle completely, so now what we're going to do is we're going to rinse this off with some ice cold distilled water. This has been in the refrigerator for overnight. The reason I'm using ice cold distilled water is that the silver chloride is slightly soluble in water, but less so in cold water. So now what we're going to do is we're going to pour off this acid into a waste treatment bucket, or a waste bucket here, and then start rinsing it with cold distilled water. Here we go. Here's what the silver chloride looks like down in our beaker. Now remember, the solution we just poured off in here is just going to be acid, dilute nitric acid with a little hydrochloric acid in it. So now what we'll do is we'll start rinsing the silver chloride with ice cold distilled water. I've got our silver chloride rinsed as best I can to get all the acid off of it. And now what we'll do is add some more distilled water to hydrate the silver chloride for the next reaction. For this next reaction, I've got silver chloride, and we're going to be adding sodium hydroxide. Oh, I forgot a number here. There's supposed to be a 2 in front of this one. So 2 sodium hydroxide, 2 AgCl. And what we're going to get out of this is Ag silver 2 oxide, oxygen, plus 2 NaCl plus H2O. So we're getting silver oxide, salt, table salt, and water by adding sodium hydroxide to the silver chloride. I've got a handheld blender here. It's got little steel blades that turn, and we're going to use that to stir the silver chloride. I've got a pail of sodium hydroxide. So what we're going to do is going to reach in here and get some in a scoop. And now we're going to add it to our beaker that's got the silver chloride in it. Here we go. I'm just going to dump it right on in, and the silver chloride will turn black as I add the sodium hydroxide and stir. And we're converting the silver chloride to silver oxide. Add a little bit more lye. Looking for a nice jet black color, and that'll tell me that all the silver chloride has been converted to silver oxide. Rinse it down. Now we're going to add some more. Let's add some more lye. We're almost there. It's more of a gray color right now, and I'm looking for a jet black color. we've got it pretty close. It's still just a little bit of a pale color. I'm going to drop in another spoon or scoop of lye. And we're going to stir it one more time here, see if this will do the trick for us. Got it now. It's looking right. I think we've got it all converted now to silver oxide. For this next reaction, we're going to be adding sucrose, granulated sugar, to the silver oxide in our beaker, and I'll post the reaction on the video on the screen there. I'm not going to write anything else on the beaker, it's getting crowded. But in order to do this reaction, I think what we'll do is, I've done this before with this much silver chloride and had it erupt out of the beaker like a volcano. So what we're going to do is we're going to transfer the reaction beaker that has our silver oxide in it into a HDPE plastic bucket to do the reaction. Let's get our beaker down into the bucket that has our silver oxide in it. You know, we're not going to really be able to see the reaction that well in here, so let me move it back up into the fume hood. And we'll try to just go real slow with this so we don't bubble it over and create a big mess. All right, here we go. Place a glass stirring rod in there. I've got a spoon down in my sugar. Here goes our first spoon of granulated sugar. Let's add it right in. Stir it up. See what happens here. Oh yeah, I can see. Looks like silver starting to form on the glass down there. See that? Yeah, there it goes. Just that one spoon of sugar is all I put in there. Wow, I've completely coated the inside of the beaker now with what looks like a mirror from that sugar. Rinse this down. Now we'll add another spoon of sugar. Here we go, another spoon of sugar going in. This is a very exothermic reaction. Creates a lot of heat. Yeah, I think the reaction's done now. No, I still see black silver oxide in there. So we're gonna have to have a little bit more sugar now. Gosh, I hope this thing don't take off on me. There's another spoon of sugar going in. You see there's still black specks of silver oxide in there. some more sugar in. And we're getting pretty close to being complete. I still see some blackness in there. That's the silver oxide that hasn't completely converted. But that's granules of powdered silver that we've converted by adding the sucrose, sugar, table sugar, like you use to sweeten your coffee or your breakfast cereal. And now we've converted that silver oxide to pure silver metal. I'm going to add one more spoon of sugar just for good measure. Make sure we've got it all converted. I think it is. Here's all our pure silver metal. Now that we've converted, that should be very high purity silver right there. 3/9 fine or better. Pure silver powder. Now we'll begin the arduous task of rinsing all the lion sugar off of the pure silver in our jar here. Oh, that's way too hot for me to pick up with these gloves. Let's go ahead and start rinsing this now. Pouring off the waste into this bucket. I've rinsed our silver over and over with hot tap water. And towards the end, what I had to do was let it settle. So I've been working on this about a day because I got to get every bit of the lion sugar rinsed off of here before I try to dry it out and melt it up into a bar. This is the final rinse. You see a little bit of silver goes over every time I do one of these rinses. And if you look down in here now, in my rinse bucket, I've probably got 3 gallons of rinse water that I've used to rinse the silver off completely. It looks real clean now. I'm confident that all the stuff is off of there. And you'll see that down at the bottom of the bucket, we've got a little bit of silver that has been poured off and settled to the bottom from those rinses. Maybe 3-4 grams, something like that down there, maybe even less than that. Now, this is a way to get high purity silver without having to go through the silver cell. It does make real high purity silver, but it's such a pain and creates so much waste. And I just want to show you here, I got some pH test strips. This is the rinse water that we've rinsed off. You can see it's highly caustic, of around pH 11 or 12, maybe even higher. Now what we'll do is get a sample of some of this rinse water out of here onto a test strip, and you'll see that we've got the solution to pretty close to neutral. So that's a good indication that we've got all of the junk rinsed off of this silver. So we should just have silver and a little bit of water in here. It's important to get all the sodium hydroxide mixed off, or rinsed off. There's going to be an excess in the sodium hydroxide in here. That's why we turn highly alkaline for the test of the rinse water. Got to get all that off of there, because when we try to dry this silver out in one of these silica pans, hot sodium hydroxide will dissolve the silica and etch the pan. So that's why I spent so much time getting everything rinsed off of this silver. I lost the battery in my wireless mic. So now what we're going to do is transfer the clean silver powder, high purity silver there, 3/9 fine. We're going to transfer it out of the beaker and into a Corningware dish. And now what I'll do is I'll get as much of the rinse water out of there as possible. And we'll put this up on some low heat and dry the silver powder completely so that we can go to the next step, which is to melt it into a nice pure silver ingot. Got it all dried off. It's been allowed to cool. And we figured there's probably going to be about 10 troy ounces of silver. So what we'll have to do is transfer it into our melt dish carefully. That's about all I'm going to be able to get in there for right now. Now we're going to put the silver crucible in a little handle. We'll take this over now to the melt table and melt this up into a nice silver ingot. Here's our pure silver bar. Came out just gorgeous. It's got a little bit of flux that came over and adhered to the top of the bar. So what we'll do is we'll put it in this Pyrex bowl, and I've got some distilled water. And what we'll do is cover this up with a little bit of distilled water. And we'll put this up on the heat. I'm adding a little bit of sulfuric acid to make a weak, dilute sulfuric acid bath. And that should dissolve off that little bit of flux that's on top of the bar. This has been in here about 5 minutes. I'm going to take this thing out. Now we'll take it in and rinse it off and see if we can get the rest of this flux off of here. Yeah. Still got just a little piece of flux right there. I think we'll stick it back in the sulfuric acid for a few minutes. See if I can get that last bit of flux off of there. I think I got all the flux off of there. There's a little bit right down here. I don't see it anymore. I think it's gone. So now what we'll do is we'll grab it out of here. Let's take it in now. See if we can rinse it off real good. Let's see what we got here now. Oh yeah, I got it off of there. That looks pretty good now. Got a little bit of a stain on it from the flux that came over. But good Lord, look at that. High purity silver. Look at them lines in there. Gorgeous. Look at them blue speckles in it. It's very high purity. We were looking for about 10 ounces. 315 grams, which is just under 10 ounces. That's what we got here. 281.7. That's 9 troy ounces. Here's our custom stamped silver bar. And this is going to my good friend David, who is a chemist, and he helped me figure out the formulas for the reactions that we did in this video. He also provided me the silver nitrate to do the video with. Let's see what we got. We should have 9.05 troy ounces, and that's exactly what we have. Special thanks to my good friend David. This will conclude the video.